Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry, we'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Surprise, surprise! It's not Amy today, it's Priya. Hi everyone, and welcome to Math Wednesdays with the Learning Liaison. I am here with you today as the guest star, Priya Prasad. So let me not waste your time. Let's go ahead and just jump right into those questions. Like Dr. Impel said, if you have questions, just go ahead and put them in the comment box. We're here to read them. All right, so first question up is, in the downtown area, a hotel measures 68 feet in height. Well, 68 feet in height seems to be important, so let's just highlight that and come back to it. And it says, at 2 p.m., the sun casts a shadow of the hotel measuring 102 feet long. Well, 102 feet seems pretty important. I have no idea what's going on with the 2 p.m., so we're just going to highlight that, put that off to the side, figure out something a little bit later. We keep reading, and it says, there is an 8-foot fountain, okay, in the middle of the courtyard. When the hotel's shadow is 102 feet, the question is asking us, what is the length of the fountain's shadow? All right, well, take a couple seconds, think about what the information is that we need and what information we don't. They like putting a lot of numbers in there because they like to confuse you and see if you're actually paying attention. So let's see if you've been paying attention. We need 102 feet. We need the 68 feet, but that 2 p.m., really not that important. Just some extra numbers to see if you're paying attention. We definitely need the 8-foot fountain. And remember, they're asking us what the length of the fountain's shadow is. So let's see, it sounds like I have 3 pieces of information and I'm missing 1 to complete all of it. So I have 4 pieces of information that I essentially need. I'm going to solve this using a proportion. If any of you have used a proportion before, it's pretty simple, pretty straightforward. If you haven't, don't worry about it. I'll help you. We're going to start with two fractions that are equal to each other, and then we're going to put in the information that fills one set of the fraction. So we're going to complete one entire fraction together. So it's going to say 68 feet because that goes to the hotel, and 102 also goes to the hotel. Okay, this is where it doesn't matter. Put those two pieces of information in. What matters is how we do the second fraction. So I'm just going to put 68 on top, and I know that's the height, so I'm going to put a big H over here for the height. And I know that the shadow is 102 feet long. I'm going to put S for shadow. Letters don't mean anything else other than the height and the shadow. We then go and read that we have that 8-foot fountain. Well, is the 8-foot fountain the shadow or the height to the second piece of information? Well, it's not the shadow because they're asking us for the fountain shadow. So it must be the height. Let's go ahead and put that piece of information in. And remember, we're solving for the shadow. So we're going to put X at the bottom. All right, ready? Get your little calculators. Large calculators, small calculators, get them out. Don't cheat. Sometimes you know math without realizing it. But let's go ahead and solve this together. I'm going to cross multiply, which means I'm going to start from the top of a fraction and multiply to the bottom of the opposite fraction. So we're going to do 8 times 102. We have 816. That is equal to 68 times x, which is just 68x. Okay, well, now we have to solve. We're looking for what x is, because remember, the x value is the value of the fountain's shadow. So let's go ahead and solve for x. What does that mean for us? It means we have to divide both sides by 68. Why are we dividing? Because 68 and x are mushed up next to each other, which means they're being multiplied, and we have to do the opposite operation. So let's go ahead and divide 68 on both sides, and we get that x is equal to 12, which, ooh, ding, 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 we have a winner. Winner, winner, chicken dinner. Letter B, 12 feet. Right? So when you're doing problems, you always want to ask yourself while you're going through the steps, did I solve what they asked me to? Did I do what they were looking for? Those are questions, because if you just start putting things in and you get numbers, sometimes if the number add up letters, you think you're done. But that doesn't mean it's an actual choice that is correct. It just means it's an answer choice. So let's keep going. Let's try number 2. All right. Number 2 looks pretty simple. It's a few words. It has an expression. Let's see what it's asking for. It says, identify the first step to simplify the following expression. Okay, well, in order to solve, we always use this thing. It has a whole bunch of letters in it, and everyone refers it to PEMDAS. So we have, please excuse my dear Aunt Sally. So we have parentheses, exponents, multiplication, division, addition, subtraction. Okay, doesn't seem too bad, but what I don't like about this is it doesn't help us solve this problem. And I'll tell you why. What we should be looking at is parentheses, exponents, multiplication or division, addition or subtraction. Why do I write it that way? We look for parentheses and exponents first. We say, okay, well, we don't have any. Let's keep moving forward. From the left-hand side, we're going to look at the expression and we're going to ask ourselves the question, multiplication or division. Which one do I see first? I don't know which one. Let's look at the problem. Well, we have addition, which is not multiplication or division. Ooh, but then we have this division and then the multiplication. So the correct answer in this case is division. I'm going to start with division and then multiply. So let's do that one more time. Remember, I'm going to start from the left and go to the right, and I'm asking myself, multiplication or division? Which one do I see first? And it just so happens that we have a division first, so our answer is to divide. Okay, so we have to take the first step of division in order to solve the expression. If you don't do PEMDAS, orders of operations, in the correct order, you will get an incorrect answer. If you don't believe me, try it out. Do division first, then do multiplication first. Tell me if your answer is different. Let's keep going. Chug-a-lugging to number 3. All right, so here we go. We have a bakery, and it's putting together spooky cookie packages for the local elementary school. The packages weigh the following numbers: 7 ounces, 18 ounces, 5 pounds, 6 pounds, 14 ounces, and 6 ounces. And what are they asking us? What is the total pounds of the spooky cookie packages? Well, we have to figure out what we need. We need all of the numbers, and we need to ask ourselves, what do we have to put them in? They have to be in pounds. So first off, there seems to be a problem. The problem is I have ounces and pounds. My answers all need to be in pounds. So I have to figure out what happened. Well, nothing necessarily happened, but I have to do a conversion. So let's convert our ounces to pounds. All right, ask yourself, if you don't know how many ounces are in a pound, do I have it on the reference sheet? Well, if you have a reference sheet, it's probably going to be on there. It's one of the conversions that I generally see on the reference sheets. But if you don't have a reference sheet, this is one of the things where you go, okay, I need to remember this. So let me inform you that there are 16 ounces for every 1 pound. Okay, doesn't seem too bad. So let's add all of our ounces together to do one conversion. So we're going to add 7 ounces, 18 ounces, 14 ounces, and 6 ounces. So get those handy dandy calculators out and let's do the math together. 7 plus 18 plus 14 plus 6. All right, we have 45 ounces. Remember, it's not pounds. All of these are in ounces. So these are 45 ounces, but that's not what we need. We need it to be in pounds. Well, remember earlier we did a proportion? We can also do proportions for conversions. So I know that there are 16 ounces for every 1 pound. Well, I have 45 ounces, and I'm looking for the amount of pounds that is. That's how I set it up. I'm going to go ahead and do the same thing where I cross multiply. I'm going to get 45 is equal to 16x. And we're going to do the last step together. Remember, we need to solve for x by itself. So we have to get the 16 away from our x. Remember, we don't like our x's for whatever reason, and we need everybody else away from them. So let's move that 16 over. We're going to divide both sides by 16. And when we do 45 divided by 16, x is equal to 2.8125. But they didn't ask us to round anything. We got to write all the decimals out. Is that my answer? Is 2.8125 my answer? Is that it? That's my pounds, right? But that's not my answer. I didn't use the 5 pounds and the 6 pounds from earlier. So I have to add that to my 2.8125 pounds. So let's add them together. Well, I know that 5 and 6 is 11, so I'm going to add 11 to what I converted. We have 2.8125 plus 5 plus 6. I'm writing it out just in case anybody needed to see all of it. Well, 11 plus 2 is going to be 13, and I'm going to keep my decimal the same. And my answer is 13.8125 pounds. If 2.8125 was an answer, you might have picked it. So you want to make sure you're asking yourself, did I answer the question? Go back and count information. There was 1, 2, 3, 4, 5, 6 numbers that they gave to us. And to get to this answer over here, we only used 4 of it, which meant we were missing these 2. In order to get the answer, we needed to use those 2 extras to get the total of 13.8125. All right? Well, let's keep chugging along together. Number 4. Let's read it. It looks small. It doesn't look too bad. Looks like a problem that will be pretty easy to solve. So let's go. It says a triangle measures 7 inches and 11 inches. Okay, that's some good information. Let's just highlight that. Now they're asking the question, which of the following statements is true about the third side of the triangle? I don't know. Does anybody have a clue? Well, I recall hearing about this rule, and it went a little something like this. If you add 2 sides of the triangle, so the sum of 2 sides of a triangle, I'm going to put the lovely triangle shape for the word triangle, they must be greater than the third side. Okay, so now that we have this lovely rule, let's figure out what's going on. We have the sum of 2 sides of a triangle must be greater than the third side. Well, I've got 2 sides. We have 7 and 11. So let's figure out what those add to equal. 7 plus 11 is 18. So it has to be greater than the third side. So it sounds like 18 has to be the largest number, but it can't pass more than 18. So how do we figure out another side? Well, sometimes you have to understand the regular math. Well, if you pick a side of 7, you're going to get an isosceles triangle. They haven't really told you much about what's going on. We don't know what type of triangle this is. So we have to think about other things that were provided to us, and we have to say that it must be greater than 7, but we know that the sum of those 2 sides are going to be 18, so it has to be less than 18 because it can't be more than that. Ready? Let's keep going. This one just says to solve for x. Sometimes it's just as simple as that. But I know a lot of you are freaking out. You're seeing a fraction, you're seeing parentheses, you're seeing a large number. There's a lot of things that scare you, right? Well, it's not going to scare us. We're going to be able to get through it together. So we're going to look at this, and we're going to start off with PEMDAS. Remember we talked about that earlier. So parentheses, exponents, multiplication or division, addition or subtraction. Well, in this case, we kind of got a lot going on. We have a multiplication and a division all in the same place, all at the same time. Okay, Priya, what do I do? I'm freaking out. You told me this was going to be easy, but I don't know. Well, remember, we still have to start with parentheses. So let's start with the parentheses. Is there anything we can do inside the parentheses? No, not really. I'm not able to simplify or mush together 4x plus 6. I can't combine them. Just undoable. So then we ask ourselves, is there anything to do outside of the parentheses maybe? Yes, and that's going to end up being a multiplication, but we're not going to do that first. Let's go ahead and tackle this fraction that we see and kind of get rid of, let's move that denominator. Let's do something other than multiplication right now. So how do I get rid or move that lovely 8 that's there? Well, I know that the 8 is being divided by everything that's in the numerator. So 8 is our denominator, 2 times the quantity of 4x plus 6 is our numerator. Well, I need to get rid or move that 8. Well, I have to do the opposite operation because that's what math always tells us to do. So let's start off there. I'm going to rewrite it off to the side, and let's do it together. All right, so remember, I said I need to move the denominator, so I need to do the opposite operation and move it to the next side. So let's go ahead and do that. We are going to multiply 8 on both sides. And the cool thing about multiplying 8 on both sides, I don't have to multiply out everything on the left side by 8. I just have to multiply the right side to 8. So what we're going to do is ask ourselves, why does it work? Well, it works because anything over itself is going to equal 1. 8 over 8 is equal to 1. 1,000 over 1,000 is equal to 1. Apples over apples, guess what? It's equal to 1. So we get lucky and we don't have to actually multiply everything on the left side by 8. We just have to do it on the right side. But it helps eliminate some of that mess that we have going on. So let's go ahead and tackle what we now have. So we're going to keep everything in the numerator the same. And we're going to multiply 100 by 8. Well, 8 times 100 is 800. All right, now think, what's the next step? Well, if you said that I should distribute the 2, you're correct. Let's go ahead and distribute the 2 into the set of parentheses. So 2 goes to 4x and 2 goes to 6. Remember, if you're an adult and you have kids, there's no way as a parent you're getting away with giving one kid 20 bucks without giving the other. So let's distribute out the 2. 2 times 4 is going to give us 8x. And then we have 2 times 6. 2 times 6 is going to be 12. That's going to be equal to 800. All right, what's our next step? We still need to solve for x, so what else is on that side that we don't want over here? Well, 8x is together, so let's move over that 12. Subtract both sides by 12, and let's keep going. Well, I still have 8x over here, and 800 minus 12 is going to give me 788. I'm not done yet. I still need to know what x is, so let's keep going. Well, I'm going to divide both sides by 8, because remember, my 8 and my x are mushed up next to each other. which means I have to do the opposite operation, which is divide both sides by 8, and what do we get? Well, 788 divided by 8 is going to give us 98.5. But Priya, our answer choices are in fractions, so where did you go wrong? We didn't do anything wrong. I didn't do anything wrong. Did you do anything wrong? I don't think we did. Only thing is, they sometimes like to give us decimals in our answers, but fractions as answer choices, so we just have to convert them. We're not scared about that. 98 is a whole number, so we're going to look at our answer choices where 98 is the large number, the whole number. B says 99 and a quarter. That's not right. And D says 99 and a half. Well, that's not right. So it's either going to be A or C. Okay, well, now we have to figure out which one it is. Well, both of them start off with 98, but how do I know which fraction gives me decimal that I have over here? We have to do math. If we have 1/2, you do 1 divided by 2 in your calculator, and it just so happens to give you 0.5. But let's say you didn't know that it was half, and you thought it was 1/4. If you do 1/4, what do you get? 0.25. Well, if 1/4 gave you 0.25 and half gave you 0.5, and your answer was 98.5, what do you think your answer should be? 98 and a half. They don't seem so bad, do they? All right, let's keep checking along. Number 6. Talking about a daycare, and they're loading up the minibus for a field trip. Okay, sounds like fun. Let's see what's going on. There are 7 children and 7 car seats, and they want to know how many ways could the children sit in the car seats. This sounds like a problem where I have to do some things, but some stuff matters as well. Let's talk about a couple ways that we do this. Okay, let's just think through the problem. If these are my 7 car seats, okay, there are my 7 car seats, and I have 7 children. We're going to make them like little aliens. There we go. 1, 2, 3. Ooh, that's really an alien. 3, 4, 5, 6, and number 7. Here are our children. Right, if I had 7 car seats and 7 children, let's say child 1. Could child 1 sit here and here and here? We've got child 1 in 3 seats all at the same time. Is it possible for one child to sit in all 3 seats at the same time? No, it is not possible. I don't know about you, but when I sit in a seat, I'm only occupying the one that I'm in. There is no way possible that I can be in my seat and the seat next to me all at the same time. So we have to figure out something else. Well, let's go ahead and try to think of another way. So if I sit in my seat and my seat is for me by itself, then I have potential of grabbing any one of those 7 kids and putting them in the first seat. I'm the adult, I'm grabbing a child, I'm putting them in, buckling them up, and then I'm going to go to the next child. Well, if here is all 7 possibilities, if one child is sitting in that seat, how many do I have left? I have 6 left for the next seat. So I take another child, I put them in the seat, and I go again. Now I have 5. I take a child, I put them in the seat, Now I have 4. I keep going, and you'll notice that we eventually get down to 1. So all 7 kids have the potential to sit in the first seat. But if one child's sitting there, I only have 6 kids left outside. So then I have 6 kids left. Then I have 5 kids. Then I have 4 kids. Then 3 kids. Then 2 kids. Then no one else but the one last kid. Then you got to pick him up and put him in the seat. That's the only way that they can sit there left. Well, this sounds a lot like combinations. And it is. And the cool thing about this is when you do the little bit of work that we've done, all you have to do now is multiply all the numbers. So you're going to take your calculator and multiply 6 by 7 by 5 and 4 times 3 times 2, and you're going to get your answer. If you use your calculator with me, we should all have the same answer of 5,040. That's it. It's not that bad. All right? Before I move on to our problems together that I've put aside, I see a problem in the chat box. I haven't ignored you, not I promise. So let's go ahead and tackle that problem together. It says a piece of cardboard measures 60 inches by 40 inches. So I'm just going to clear out this page and let's go ahead and do the work down below together. In the future, I promise, I will leave extra space for questions. So this is not a part of what we're doing. Okay, so we have a piece of cardboard and it measures 60 inches by 40 inches. So let me just draw our cardboard, 40 inches, 60 inches. And it says, what is the maximum volume of the box that could be formed by cutting squares of equal size out of each corner of cardboard? So the maximum volume. Then we have to round to the nearest whole number. Okay, so we're taking something that we think is 2-dimensional, turning it into something 3-dimensional. How are we doing that? We're taking our cardboard and it said we're cutting out squares. So we know that no matter what we do, it has to be equal. They look more like rectangles, but we're going to pretend they're squares. It has to be equal on all 4 sides. So let's say I go ahead and cut out 2 inches. I'm doing that 4 times. I'm cutting out 2-inch squares all over the place. Well, not all over the place, but in the 4 corners. So you have to take into account that your measurement started as 60 inches and 40 inches. So we can cut as little as 1 inch, potentially half an inch off of each side. Our answer choices will help us in this case. Let's say that we needed to cut off 2 inches. If I cut off 2 inches, remember my 40 is being affected by this 2 inches and these 2 inches. So my 40, once I fold my box, is changing, right? Because what's happening is I'm taking my 2-dimensional shape and I'm turning it up. I'm folding along these dotted lines and I'm making an open box. My box is essentially going to look something like this. Okay, that's kind of what my box is going to look like. I'm going to take it and it's going to fold into this box. So what's happening is when you do your measurements, you have to remember for a cube, volume is equal to the length times the width times its height. Okay, well, I'm going to be able to get my length and width, and then we're going to have to think about what our height is going to be. So my measurements are changing, and they're changing kind of quickly. So I'm going to erase my original. drawing, and I'm going to put my three-dimensional object over there. This will allow me to put numbers and see what's really going on. So we're starting flat, we're changing it to three-dimensional. So right now, this is my 60 if we're looking at it, right? Let's start there again and do some measurements. If I'm subtracting 2 inches on both sides, my 60 is now being subtracted by 2 inches and 2 inches. So I'll have 60 minus 2 minus 2 to give us 56 inches. I'll then do the same for my 40. 40 has 2 inches and 2 inches, so I'll do 40 minus 2 minus 2 to give me 36 inches. Well, remember, we had to fold up the sides to figure out what was going on. Well, how deep did I cut that box? Remember, it's a square, so we cut it by 2 inches. So the height on this is 2 inches. We will then solve by doing length times width times height. And we're getting this problem was asked in the comment section. I did not go ahead and type it up. I just kind of erased the problem from the work that we did and put this one in. And I said the lovely black box is separating the work from the comments from the work that we did earlier. So when we multiply, we're getting our answer in a cubic measurement. I don't know if our answers are going to be in inches, but if they are, it's going to be 4,032 inches cubed. So it really depends on what your answer choices are, Jamie, because your answer choices will essentially help you figure out how much you're kind of taking off, right? If you're taking off half an inch, or you're taking off 2 inches, or you're taking off 3 inches, it's really going to change how the problem can be solved. You can do manipulations to your box by cutting out those squares to figure out what the volume would be. So I chose 2 inches. I don't know what the answer choices are, but essentially this is how you would solve through those cardboard, right? You'd start with your cardboard piece. You would take some measurements that you think will help you get to where you need to be, because what we're doing is we're trying to maximize the volume of the box, right? If it's too difficult to do that, there are other ways of approaching it by figuring out what other numbers could be used for your squares. It's essentially a guess and check at that point, because they're really not giving you the square corners. They're only asking you to figure out the maximum. So if you're doing this, it's kind of one of those things where you're just going through and figuring out what best squares to cut out to still give you larger volumes. Remember, sometimes the larger the number, the smaller the volume, because what you're doing is you're cutting out larger chunks of your cardboard box. So maybe even start with half and see where that takes you, and that will essentially give you larger volumes than where I'm at. 20 cubic inches wouldn't make sense, because 20 cubic inches is a lot smaller than where we're starting. So it would have to be cubic feet, and you would have to convert first in order to go through any of that. Hopefully that was able to help you through that a little bit more. And if not, we can always chat about that a little bit later. Back to some of the problems I prepared for us. So we have a teacher, and they're asking students about books that they read for pleasure. Let's be honest, kids really aren't reading that much these days, so these numbers really shouldn't surprise you. It says more than half of the students hadn't read any books. About 30% of the students read 1 book, and whoever's left, they read 2 books. And they want to know which of these statements down here is true. Well, I don't really know what's going on. You're probably just as confused as I am. So let's figure out what's going on. Let's read the answer choices. I see the mean and median are the same. The mean and mode are the same. The median and mode are the same. And the mean is greater than the median. Well, these are all words that I know. And I know that I need numbers to actually be able to solve this stuff. But I don't see any numbers. Where am I getting my numbers from? Well, did they tell us how many students are in the class? I'm double checking and I don't see any. Did they tell us any specific numbers? Like 3 kids read 2 books or 5 kids read 0 books? No, they just gave us more than half, about 30, remaining. That's not enough information. Well, that means we have to come up with a little bit on our own. So let's go ahead and figure out how many kids we want in our class. Ask yourself, how many students in your classroom? I'm hoping that you go with the number I'm thinking. Let's see if my psychic powers are working today. And I'm going with the number 10. Got 10 fingers, 10 toes. It's never failed me, so let's try it. If I had 10 students, I would start by drawing out my 10 students in lines on the bottom. So I have 1 student, 2 students, 3, 4, 5, 6, 7, 8, 9, 10. All right, I'm a Picasso, I know, thank you. So now that I have my 10 students, what does my information say? It says more than half. Well, what is half? Half of 10 is 5, but we need more than half, which is saying more than 50%. And more than 50% of the students hadn't read any books. Well, if 50% is 5, then I just need more than 5. That sounds like 6 to me. So there are 6 students that read 0 books. It's then leading us to about 30% read 1 book. About 30% of what? Remember, they didn't give us any numbers. It's about 30% of what we have left because we made up this number. If they told us 10 students, 30% of 10 students, see where that would give us. But we made up this number. So it's 30% of what we have left, which is 4 students. Okay, well, let's get the calculators out. 30% as a decimal is 0.30, and we're multiplying that by 4. Well, 0.3 times 4 is going to give me 1.2. I don't know about you, but there's no such thing as a 0.2 student. So about 1 student read 1 book. Remember, the remaining kids read 2 books. Okay, so quick recap. Where did I get the 10 students from? We made the 10 students on our own because they didn't give us any numbers specifically. So we had to come up with an amount of students that were small enough to work with quickly, but large enough to give us a proper answer. I chose 10. Okay, 10 fingers, 10 toes, hasn't failed me yet. From those 10 students that we elected to be in our classroom, we had to use the following information to get our numbers. They told us more than 50% of the students in the class had not read any books. So I know that 50% of 10 is 5, but we need more. So I went to 6. And that's how we got 6 zeros. Then I kept reading the information, and it said about 30% of the students had read 1 book. So from the remaining amount of students, we needed to figure out what 30% was. 30% of 4 gave us 1.2. There is no way we can have a 0.2 student So we had one student who read one book. And the information and led us to the rest of the students, which happens to be three. Three students read 2 books. Now we still need to figure out the information from the question from the answers. We have to solve for the mean, the median, and the mode. Well, I'm going to start with the simple stuff. I know the mode. Mode is the most. So the number I see the most is 0. My median will be the number in the middle. So let's do my median. Cross out, cross out, cross out, cross out. We're just going to cross them out until we get to a guy in the middle. Whoop. 2 guys in the middle, just so happens to be the same number. So it's got to be 0. And the mean, what is the mean? The mean is like saying the average. So I'm going to add all of my numbers and divide by how many numbers. So add my numbers and divide by amount of numbers. So when I add them all up, 2 plus 2 plus 2 plus 1. So 2 plus 2 plus 2 plus 1, all divided by how many students? 10. I'll get 7 divided by 10, which is equal to 0.7. My mean or average is 0.7. So let's read through our answer choices and see which one works. It tells us that the mean, which is over here, and the median are the same. No, 0.7 and 0 are not the same. So that does not work. It says the mean and the mode are the same. Again, 0.7 and 0 are not the same. The median and the mode are the same. They are. That's going to be our answer choice. All right, you have an answer. It's winner chicken dinner, and you move forward. We have a box, and the box contains some information that we need. So we have 4 red balls. I'm not going to highlight in black, so I'll just highlight in yellow. 2 black balls and 3 green balls. Okay, so what's up with that? It says a ball is drawn at ransom. It's not ransom, it's random. I apologize. So a ball is drawn at random and then placed, and another ball is drawn. So what's happening with our balls? It sounds like when you take something out, you put it back. So if I start with 2, so let's draw a bag. Here's our bag, right? If I start with 2 balls, if I take this one out, and it comes out here, I'm going to put it back in, and we're going to start with what we're going to have what we started with. So essentially, nothing's really changing, right? But then they ask us, what is the probability that the first ball is not red and the second ball is not green? Okay, well, I always have to start and ask myself, well, how many balls am I drawing? Or how many things am I removing? I'm doing this 2 times. So I'm going to have 2 fractions. If I was removing 3 balls, pulling 3 balls out, I would have 3 fractions. So let's start with our 2 fractions, fraction 1 and fraction 2. How do I know that I'm going to multiply them? This is a probability problem. We're figuring out the probability of something happening. How many chances? What's my odds, right? Remember, in our fractions like this, the top number is always going to be what you're looking for, what you're pulling. And the bottom number is always going to be your total. So we have our pulling number and our total number. So if we started off with the total, remember we had 4 red balls, 2 black balls, and 3 green balls. Our total is 4 plus 2 is 6. 6 plus 3 is 9. 4, 5, 6, 7, 8, 9. Just making sure. We start with 9 balls. Okay? Well, what are we pulling? The first number or amount of ball, color of ball that we're pulling is not red. Well, if it's not red, then what is it? If it's not red, then it must be black or green. Well, what are my numbers for black and green? 2 and 3. So I have a 5 out of 9 ball chance of pulling not red. Remember, when I take something out, I put it back. What's the next part asking? They're asking for not green. So if it's not green, then it must be red or blue. Well, I meant red or black. So 4 and 2 will give me 6. Remember, I still have the same amount of balls in the bag. And in order to solve this, we multiply straight across. 5 times 6, 9 times 9. Well, 30 over 81 is not an answer choice. So let's figure out what is an answer choice. Let's go ahead and put it in a fraction form, and then we can figure out which fraction gives us the same decimal. I meant to put it in decimal form, not fraction form, guys. I apologize. So let's go ahead and put it in decimal form and figure out what's going on. So 30 divided by 81 gives me a lovely decimal of 0.37037. So it's going to be repeating. Okay. One of my fractions in the answers are going to give me the same decimal. So let's start with A, 4 divided by 27. Well, that gave me 0.148. That's not what we're looking for. 2 divided by 9, 0.22. 22222. It's not what we're looking for. 9 divided by 24. 9 divided by 24. Oh, look at that. Still not the answer we're looking for. So it must be the one that we didn't do yet. 10 divided by 27. Winner, winner, chicken dinner. 10 over 27 is the same as saying 30 over 81. They give you the exact same decimal. So that must be our answer. All right? So when doing problems like this, you always want to start by asking yourself, well, how many things am I pulling, or how many things am I drawing? How many things are we changing? Like, those questions. How many times am I doing it? In this case, we're doing it 2 times, which means we're going to have 2 fractions. The same thing as tossing a coin. If you're tossing a coin 2 times, you're going to have 2 fractions. If you're tossing a coin 3 times, you're going to have 3 fractions. So keep those little things in mind. And then something else that really does come into play that's really important here is that even though you take something out, you put it back. If it said you took it out and you kept it, things are changing. Things are changing in more than one place, right? Because we're changing the amount of total balls we have in our bag, and we could potentially be changing our numerator as well, right? So those little details are the things that matter the most to us when we're solving these problems, right? So how many balls am I taking out? So I have my 2 fractions, and then if I take something out, do I put it back? Remember, the first problem, the first fraction, the first fraction is what I'm starting with, and the second fraction is going to be what I have now. So if things change, it's what I start with and then what I have now. All right, guys, we got to number 8. We did an extra problem from one of you guys today, so I really hope that I was as helpful as possible. Again, I'm not Amy, I'm Priya, but that was the surprise today. I hope you guys all the best, and remember, it's not if you pass, it's when you pass. Hope to see you guys next week, or maybe it might be Amy. Who knows? There'll be a surprise.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.